So now we want to make the character physically jump. We want to click on the character and we want to add rigid body. And I'm going to create a new script called jump. C# script, jump. And it's going to be an ability. I'm going to click on landing just to copy paste and copy into the jump script. Then I got to change the name. Jump. And we're going to get rid of this. So now we have a new script called jump. And I want this script to be able to access the rigid body that we just added. So I'm going to go to character control. Here it is. And I'm going to create a variable called rigid body. And I'm also going to create a public variable called rigid body. And every time you get it, if the private variable, if the private variable is empty, is null, then you want to find it. And then return it. So if I go back to the jump script, all I got to do is find that variable. First, I'm going to get the character controller. And then I'm just going to access the rigid body and I'm going to add force. And it's going to be an upward force, vector 3 up, multiplied by the amount of force we want. And for that, I'm going to add another float variable called jump force. And this will be added as a force to the rigid body. Save and go back to Unity. And I'm going to create an ability called jump. I'm going to name it jump normal. You might notice a pattern here. I'm naming it so that I can recognize him easily. So I go to the jump ability and I'm going to add whatever number I want, 350 for now. And now I gotta go to the animator, go to the jump ability, add behavior, add a character state, and then I'm gonna add that object, which is called jump normal. As soon as this animation starts running, which means on enter, this line is going to be called. So we'll be adding the force onto the player. But before we do the physics part, we want to add some hard surface below the player. We don't want it to fall. So I'm just going to create a cube, place it below the player. I'm going to put the player at 0, 0, 0, and the cube is going to be slightly below that. And I'm going to scale. So it's like a 2D platform. Then I'm going to click play. And when we press space, the force gets added to the cube. The problem is that the physics does not match the animation. We're going to fix that. So exit play mode. I want to match the box to the player. So I'm going to go into isometric mode. And we can move it. And make it fit the player. Okay, that seems about right. We also got to fix the width. The width doesn't really matter because this is a 2.5D, but I'm going to change it anyway. And click apply. I want to change the camera position. We can move it around by dragging it, but there's a shortcut. Move around the scene view like you are the camera. Get to the right position. And once you're done, click on the main camera and press Ctrl-Shift-F. That's going to move the camera to directly where you are in the scene view. Now here comes a bit of challenge. You want to figure out exactly when this collider hits the surface so that you can match the animation. I'm going to go into the character control. And as soon as this object awakes, meaning as soon as the game starts, I want to look for that box collider. Box. And I'm going to get it from the game object because this script is in the same game object. And I want to figure out its bottom position as well as the top, the front, and the back. Basically 4 sides. And we can do that by accessing something called bounds. We want the center, Y position, minus the length of the box. This is not the length. Extends basically means half of the length, half of the height. We get the bottom part, and we get the top part by doing the opposite, by adding the exact same amount. And it's the same with front and back, except it's not Y. For front, it's Z plus Z, and the back is going to be minus Z. So let me go back to Unity, and if I look at it from the side, this would be the center. If you add, you get the top, minus Y, you get the bottom, plus Z, you get the front, minus Z, you get the back. That's the idea. On each of those corners, I want to create an object. So I'm going to create a sphere. I want to make it small. 0.01. So it's really small. And I'm going to name it Collider Edge. And you don't want it colliding into anything. You don't have to render it either. 0.25 seems about right. Okay. And I'm going to turn this into a prefab by dragging. I can delete it. I'm going to instantiate that prefab during runtime. So if I go back to character control, I want to create a public variable, public game object called Collider Edge prefab. Save and go back to Unity. We now see the variable here. And I want to drag that prefab into that window and click apply. The speed shouldn't be here. We can delete this. We're taking care of speed in our abilities, not in our character control, so we don't need that. Now I'm going to come back to the code, and I want a function called create edge sphere. That takes in the position info and simply create the instance. And you want to instantiate it into the position with 0 rotation. And return the game object. I'm going to go back up and create a list of game objects that holds those spheres. I'm going to call them bottom spheres. And we want to instantiate them on the bottom front and back. And we already have the positions here. X will always be 0. Y for bottom is bottom. And we just take in the front value as well. Okay. And bottom back, we do the same process. Except the Z position is going to be back. Let's go back to Unity, click play and see what happens. So these two spheres have been added to where the player was, but they're not following the player. Let me go back and turn on the render just so that we can see it. Then I'm going to go back to the code and put those two objects as the child of the player. So the bottom back's transform's parent is going to be this transform. Save and let's go see what happens. I'm going to create a material because I want to see the spheres better. Edge sphere. And I'm going to make it red. I'm going to go into the prefab window and drag the material into the sphere. I think I have to play the game again. So now we see two spheres exactly at the front and back. I'm going to go back and I want to add them to the list. So add them to the list. I also want to create 5 spheres in between these two things. So if we have the front sphere here and the back sphere here, I want to get the length of the vector here divided into equal sections, and each of them is going to have a sphere. So first I want the vector in between, which is bottom front minus bottom back, and I want the magnitude and that is going to be 1 section. I've got to divide that by 5, so 5 different sections. This would be the length of a single section. And in order to repeat that 5 times, we simply use a for loop. And each of the position is going to be starting from the back, and we want to add X amount of sections. Forward is just the direction. We want to multiply that by the length of 1 section into the number of iterations that this is taking. In simple terms, this is 1 section, this is 2 sections, 3 sections, 4 sections, 5 sections. So it's multiplied by 1, 2, 3, 4, 5. We get equal length in between. And once we have the position, we have the function that we created. Just add the positions in there. And let's see what happens. What the hell? I think we forgot to create a list as a new game object. That should fix it. Let me go back. And we also want to add all the in-between spheres. We want to add them as a child to the player. So their parent is this game object. And we also want to add all of them to the list. Okay. Let me click play again. So we have spheres at the bottom of the collider, except we have 1, 2, 3, 4, 5, 6, 7. We don't need the one at the end. So these are 2 different spheres in the exact same position. So I'm going to accept play mode. I'm going to go back to the code. And we only have to do this 4 times. Let's go back and play. Okay, 1, 2, 3, 4, 5, 6. And they're going to follow the player wherever he goes because they're under the hierarchy. Whatever positional changes that occur here gets applied to everything below. We don't want the character swaying like that. Exit play mode. Go to rigid body. Go to the constraints. And we don't want any rotation. Click apply. I'm going to save the scene. And let me click play again. Okay. Now that we have the spheres, we can start using them for ground detection. Go to character control. I'm going to create a new transition parameter called grounded. I'm going to go back to the animator and create the parameter there. Bool grounded. I'm going to go to the state scripts and create a new ability called ground detector. And again, it's going to have the same format. Copy and change the name. And delete this. And on every update, we're going to look at the character control. And I want to create a new function for ground detection that takes in the character control parameter as a parameter. And one of the most obvious ways to detect the ground is to check if the velocity has become 0. So if the character's rigid body, we look at the velocity, and if the velocity y is 0, it means the character's not falling at all, which means he has hit the ground. The problem with this is that velocity y is a float value, so it means that it's not going to be at exactly 0 most of the time. So we need to give it a range. If it's below 0, and if it's somewhere between 0 and minus 0.01, we'll consider it to be 0. Control rigid body velocity y is bigger than. So this will be the range where we consider velocity to be 0. In that case, we return true because we know it's grounded. And then we could also look at each of the spheres that we created. So for each of the game objects in the list, wait a minute. That has to be a public variable. Okay, so for each of the spheres, we want to do a raycast. If we draw a raycast from the sphere's position, and we wanted to shoot it downwards, so negative up, we want to take a look at it. And for max distance, we want to specify. So let's create a public variable called distance. And put it in here. If the raycast hits anything, then we return true. Otherwise, the character is still in the air. To explain this in simple terms, consider raycast to be lasers that shoot straight forward. In this case, we're shooting it straight down for each of the spheres. But we don't want to check for a ground that is miles away. We want to check for a ground that is almost hitting the player. So this will be the distance. In most cases, the distance is going to be 0.01 or 2. So if the ground comes this close, it means the character has hit the ground. So that's the basic plan. I'm going to go back to the script. And I want to be able to see those lasers in the scene view. So I'm going to use something called draw ray. And we want to draw it exactly the same as a raycast. So take the position. Again, we want to shoot it downwards. So negative vector 3 up. And for debugging, we could just come up with a random number, 0.7 or 8. And we want to color it yellow. So I'm going to go back up to the update. And if the character is grounded, then we want the animator to say the parameter grounded is true. Otherwise, grounded would be false. Let's go back to Unity. And in the states folder, we're going to create the object that we just created, ground detector, and name it player jump normal ground detector. And we're going to add this into the state. Add one more slot. Add the ground detector. And here we want to add a new transition condition. So instead of having an exit time, we want the transition to happen when the character hits the ground. So get rid of the exit time. If grounded is true, we move into landing. Let's see what happens. So here the character goes into the jump animation, and once the ground is detected, we go into the landing motion. And here we also see the raycast. I think I forgot to set the distance. So I'm going to set this to 0.025 maybe. Even if there's a mistake here, when the velocity becomes 0 and the character hits the ground, we get the same effect. So that was good. If I increase this number to 1, that is going to be way too big. So even before the character hits the ground, the raycast is already hitting the ground that is a meter away. I'm not sure if this is in meters or whatever, but we want the distance to be small. Let me add one more variable. So I'm going to quit. And I'm going to go to the ground detector script. And I'm going to add a variable called check time. This is going to be in percentage. 0.01 to 100. Because for a jump ability like this, I want the character to take off into the air and then start checking the ground. So we want to make sure that the animation has reached a certain point. State info normalized time. This is in percentages. If this is past the check time, that's when we start checking. Okay, let me go back to Unity. Go to the states. And I'm going to say maybe 10%. That should be enough. By the time the jump animation has gone through 10%, the character should be already in the air. So let me click play again. It's not going to make a difference. This is just a fail-safe. So we have the exact same motion and it's working fine. We still have a lot of work to do, but I'm going to end this video here because I don't want to do too much for a single video. So that's it for today. Thanks for watching. I'll see you guys soon.